Okay, in this section, we're going to talk about projection. Eventually, we're going to discuss projection of a vector on a vector. But before that, let us talk about projection of the concept of a projection of a point on the line. Now, there are actually two cases. The first case being, let's say P is not on this line. Okay, P is not on the line. The projection, the definition of the projection of P on a line here, on this line, is actually quite simply just dropping a perpendicular, right? Dropping a perpendicular from P to the line. And Q is therefore the projection of the point P on the line. So basically, it's like dropping a perpendicular. All right, basically, it's like dropping a perpendicular. What if P is on the line? So if P is on the line, the projection of P on the line, there's nothing to drop a perpendicular. So this point itself is just a projection. I think it's quite clear. So I put it in words. Okay. If it's on the not on the line, if P is not on the line, then basically it's the foot of the perpendicular. If it's on the line, then it's the P itself. This is quite easy. What if now I have, let's discuss what is the projection of a vector on a line. Let's talk about line. This line has no direction. So suppose I have a vector, okay, I have a vector PQ like that, okay, where the endpoint Q lies on the line. Okay, endpoint Q lies on the line. Now, the projection is of PQ on the line is basically MQ. You just project M, I beg your pardon, you just project P on the line, which is you drop a perpendicular, you get M, and then you project Q, the endpoint on the line, it will be Q itself because Q lies on the line. So actually, this one, the projection is quite simply MQ, right? Now, case 2, what if there are no endpoints on the line? So for example, so you can contrast, let's contrast this one and this one where there are no endpoints on the line. That means PQ is up there, L is here. If I want to project PQ, I project P individually, I get M. I project Q individually, I get N. I get M. The projection is quite simply just M. N. All right, so you have two separate cases. Okay, two separate cases. So I put it down in printed like that. All right, but actually quite loosely speaking, it is almost like, if I may draw, it's almost like, imagine you have a sun here, and then you cast the shadow from the top, and then the shadow is actually MQ, the shadow is actually MN. Correct? And the direction of the shadow, is, it follows the direction of the original object. So I put it down in words, generally speaking, therefore, okay, right? Intuitively, it is just casting the shadow of PQ down on L, where the sun rays are landing perpendicularly. All right. So we have defined that, but very intuitively, most people will think of it as just casting a shadow. Projection is just casting a shadow. All right, that's that.